So Vinay, why don't you tell us what is OMP?
Yeah, let's go there. So what we have here are two edge devices at two different sites. Let's say we have two controllers or vSmarts. And we have your LAN segment residing over here behind VH 1 with a user 1 here. Again, VPN 1, your LAN segment in another office where there is user 2. What you want to do is create a virtual private network between user 1 and user 2. So how does this happen? So let's say user 1 has an IP address X and user 2 has an IP address Y. What we had discussed in the previous lecture is we have a tunnel, a control plane set up between the edge and the vSmart using a standards-based protocol. This could be either DTLS or TLS.
So before we go further, can you just explain the difference between DTLS and TLS?
So to keep it very brief, one's using UDP, TLS is using TCP. So the only difference in actual control plane bring up between DTLS and TLS is how we get past the NAT, and that's a whole separate lecture on how we can get past the NAT for each of these protocols and how you want to.
So in principle, the main distinguishing factor between them is whether it's TCP, or
UDP. So we are using these standard protocols. So what happens?
So just to clarify for the users, DTLS is the protocol leveraging UDP as the mechanism for carrying, and TLS is a TCP-based protocol.
Yeah. So now that we have this secure channel or tunnel set up between the edge and the controller, what we can do is run a proprietary protocol within this tunnel. So it's like saying I have this link up. I really don't care what wave goes through this link, okay? Because this need not be standard. What needs to be standard is actually what's running between these, not what's running inside this tunnel. So what we have over here is OMP, or Overlay Management Protocol.
So what we've described here is you have a secure connection between the edge and the controller based on TLS,
yes,
or SSL-based tunnel, inside which we're running the routing protocol OMP.
OMP. So OMP is pretty analogous to BGP, but it gives us a lot of flexibility. Because it's non-standard, we can extend this at will, we can add functionality, we can actually add labels at will to actually get new features in to the edge boxes without actually having to upgrade the entire network. You could leverage OMP to get your vSmarts to become smarter really fast.
So coming back to the question that you'd raised about route targets, because this isn't classical BGP or MPBGP, we don't necessarily have route targets in the same fashion, but OMP is providing us the capabilities that what we would have expected traditionally.
Yes, so in between the DTLS connection, we run OMP.
Yes.
Got it.
So now what happens is this IP address X of user X is propagated from the edge towards the controller using OMP, and then propagated back to the far end edge using the OMP session between the controller and the edge.
Another interesting question is when I advertise my TLOC to a vSmart, is that the first workflow, and then advertisement server-side VPNs? Is that the sequence of advertisements?
So yes and no. So what we are, the TLOC is also another route for OMP. So each of the VPNs
So,
is a-
so I suppose what you're describing is all the different things that we've looked at, the VPN, the TLOC, the protocol that's carrying that information for us in the system for SD-WAN is OMP.
OMP. So everyone subscribes to OMP. So any VRF or VPN is a subscriber of OMP. So it really doesn't matter. So VPN 1's treatment about a view of OMP is the same as VPN 0. For VPN 0, the only routes that it has, or the major routes it has, consists of the TLOCs themselves. So VPN 0 is telling OMP, hey, I have these routes, which are the TLOCs. Please propagate them down to the far end. VPN 1 is subscribed to OMP as well. So it's letting OMP know, hey, I have this route X, please propagate it to the far end. What the far end does with those routes is just like how a VRF would be treated. You would have a separate routing table for each VRF. So you would have a routing table for VPN 0, which would consist of all the TLOCs in your network, and hence also consist of information to establish these tunnels between the endpoints. And then it would also have a routing table for each of the VPNs or VRFs that are on the service side. So it'll have a routing table for VPN 1 at each end as well.
So OMP is providing us the routing functionality.
Yes.
Now that we've looked at the terminologies for VPN, for TLOC, for color, for OMP, can you highlight some of the additional terms that we use within the SD-WAN solution?
So the other terms, what we need to discuss from the chart, the tree I had drawn previously, is we've reached the TLOC. The node is the edge itself. We treat each site to be of significance in terms of managing. A site could consist of different nodes. And if a site consists of multiple nodes, you really don't want to establish connectivity between those two nodes themselves. So you could have a site that's front-ending the same user. So you don't need a loop right here where VH1 is talking to VH2 while front-ending the same user. So in that case, we have something called a site ID. That's a property of every edge. So edges that have the same site ID do not share TLOC information with each other, and hence do not form a IPsec tunnel between each other. And it makes logical sense for us because, hey, if you have to talk to someone within your network, you have direct reachability. You really shouldn't be terminating on an edge device anyways. It's for far-end connectivity where you want to actually end on the SD-WAN device.
So a site ID for us is just allowing us to simplify the fact that there could be, and usually are, multiple devices in the same site.
In the same site. So for redundancy, a data center could have 6 devices sitting in the same site. You don't want the data center devices talking to each other. It's basically for the spoke sites to all terminate on the data center itself. In those cases, you're using site ID as a unique identifier for a particular site that's hosting more than one edge device. So
one question on multiple branch offices can be connected through SD-WAN, but if they want segmentation, can site ID can be used to segment them between a branch office which is sales and maybe another branch which is back office?
So in that case, you'd leverage the VPN itself, the VRF itself. If a VRF doesn't exist on a box, the routes for that VRF are not advertised to it by OMP. So if VH1 has a VPN or VRF1 on it, and VH2 has only VPN2 configured on it, VH2 is not going to even see VH1 in the network in terms of VPN1.
So our VPNs are our segments, our layer 3 boundaries.
Great.
So that's how we segment our network in terms of VPNs. Since our controllers, the vSmarts, are in a full mesh, constant connected state, they are in an active-active mode. they have a view of all of these segments, all of these routes, which helps us actually drive the view of your network through the vSmart itself. You can now further segment or leak routes between VRFs using the controller, which has a view of the entire network. So here, each of these vSmarts has a view of all the VPNs that exist in your network, irrespective of what a particular vEdge has or doesn't have.
So we're very clear on the VPNs represent our network segments, OMP represents our network protocol, and the vSmarts are our controllers. Vinay, can you elaborate on some of the special nuances with our VPNs now that we have this notion of the WAN and the LAN?
Sure. So that's a good question. So what we do in terms of our VPN segmentation itself is much like our architecture. You have your WAN segment. We reserve VPN 0 for it. You have your LAN segment. This could be anything from VPN 1 to VPN 65535, with the exception of another segment, just like the architecture, the management segment. So you would want to have management connectivity and out-of-band connectivity for your device itself, whether it be the controller, the edge, or the NMS. And this has a reserved VPN called VPN 512.
So this management VPN, is this routed in our network, or is this purely for isolated management purposes?
It is completely isolated. This is the one VPN that is not subscribing to OMP. So you are not going to see the VPN 512 routes leaking across your network. It's supposed to have context for manageability of a particular device at a particular site. So
it's similar to just an out-of-band,
yes,
local-only management
VPN. Yes. So this pretty much covers all the VPN segments that we have. We've discussed about OMP. We've discussed about the controllers, what a site means, what a TLOC means, what a node is in the network. So do you guys have any further questions?
I have a question, Vinay.
Yeah.
With regard to the terminology for our VPNs, are there any other terms that we use to refer to our VPNs?
Oh, I'm glad you mentioned that. I almost missed that. So anything residing on your WAN segment, we term as transport. And anything that resides on your LAN segment, we term as service. Another way to distinguish it is anything in VPN 0 or our proprietary VPN, we can call as a transport VPN. Anything that resides on a customer's VPN is a service VPN. On the same lines, you would see interfaces on the edge devices being called service or transport based on where they reside and what properties they have. So you could have, the moment an interface connects into a circuit, it essentially becomes a transport VPN, a transport circuit for us, a transport interface for us. So you hear the transport side and the service side pretty often.
And would the transport interfaces be where the TLOCs reside?
Yes, hence the term transport location. So yeah, the TLOCs all reside in VPN 0, your transport VPN, your WAN side. And we call it transport is because it is the interface, it is the network through which you overhaul your data all the way across the internet onto the other edge device. So it is our transport location, our transport circuit, our transport interface. So yes, you'd hear the word transport and service pretty often in our day-to-day speak for SD-WAN.
So I have one quick question.
Yeah.
Earlier you mentioned one vEdge device can have multiple circuits.
Yes.
Is it possible to have multiple service providers connecting to the same vEdge device through different circuit, can have the same color and same properties?
No. So they have to have different colors, because if you don't have different colors,
okay,
then it can't be located distinctly at the far end.
Okay.
But they can have two colors having similar properties. So if I have an AT&T public internet circuit and a Verizon public internet circuit, I'd give them both public colors. And public colors inherently have the same property that, hey, I can connect to any other circuit using my NAT translation. So you can have as many providers connecting into the edge without any problem. You can't have the same color, but you can have the same type of color.
So we can be provider agnostic, but we need to have unique tagging to identify each provider coming in.
So we leverage that for a lot of performance metrics. So metrics that we want to measure in the system for our performance routing, so on and so forth, to actually distinguish which circuit is what instead of clubbing them as one single unit. So you can actually get better application performance,
tracking and logging and
logs,
okay,
and all in such capabilities. Any other questions you guys have?
No, we are good.
That was great. Thank you.
Okay, that's it for me.
Thanks, Vinay. In this session, we explored the terminology that is used within the SD-WAN solution. It is fundamental to understand these terms as they are used within this solution. Thank you for watching this video.